Welcome to the Digital Enterprise Society podcast, addressing all aspects of the digital enterprise, inspiring connection without boundaries and creation without limits. Thank you for tuning in. Here are your hosts, Thom Singer and Craig Brown.
This is the Digital Enterprise Society podcast. This podcast addresses strategies to enable enterprise transformers and decision makers to understand how digital tools and techniques deliver superior results in the global competitive marketplace. My name is Thom Singer, and I have the honor to co-host this show, yes, every single week, with Craig Brown. Craig is an industry veteran, and he's a former PLM leader at General Motors. Craig continues to serve the community of PLM as an advisor and a mentor. Hey, Craig. It's Tuesday. Here we are again.
Hey, Tom. It's good to hear your voice, and I'm happy that we're doing another one of these. In fact, we've got quite a few in the next a little bit of time, so that's good. And I have to do that, everyone, because I'm going on a vacation shortly. So
we're pre-recording a couple of episodes because Craig is off to explore, but we don't want to let you down. We want to show every single week, and we've got some good ones in the can. So everybody make a note every single Tuesday, tune in, or is it Wednesday? Tune in to make sure you're getting the newest episode of the Digital Enterprise Society podcast. Because every week, Craig and I try to bring to the show interesting interviews and other ideas to enhance the careers of all the listeners. And today we are joined by Jim Markwalder. Hey, Jim, welcome to the show.
Thanks, Tom. Appreciate it. Good to be here.
Good to have you. For those of you who don't know Jim, he is the U.S. Federal Sales Executive and Industry Manager for PROSTEP Inc. Now, what they do is they sell the PROSTEP products to the federal government. So really, anybody with a .gov or a .mil, as in military, email address is within the parameters of who he sells to. And they sell PLM products, but they're vendor neutral. And they work in data migration, data collaborations, system implementations, and they do consulting. So they have a wide swath of this world of PLM. So we're glad to bring Jim to the show. So Craig, take it away.
Hey, Jim. Well, thanks for joining us. And a lot of times the guys in the car industry don't know what federal systems is. On the other hand, one of the largest federal or military installations is here in Detroit, where you and I live. What I wanted you to describe is who are the big customers here in the Detroit area? Is it just the ground systems guys for the Army, or are there others?
No, actually, Army's a big one. If you look at the federal government and you talk about who's actually doing engineering and then would be involved in utilizing the kinds of tools we're involved with, you'll find several agencies, NASA, of course, and they're located not only in Texas and Florida, but they've got about 14 offices nationwide. Then you find Army and Navy, and of course, TACOM is one of them. Here locally. Navy, believe it or not, very interesting. I think maybe because of shipbuilding and the nature of missions while they're at sea, does some of the most innovative engineering work around.
Yeah.
So they're very big. And then surprisingly, in fact, I was surprised to find this out when I got involved, is the FDA. As it turns out, the manufacture of drugs is very specific when it comes to process control and requirements. And that is an element of product design. And so they're also a fairly large user of requirements tools and process tools.
Yeah, actually, in our PLM domains, one of the big vendors, it's the guys from France, they were a huge benefactor of the pandemic. Yes. Because of processing and vaccine development. And they acquired a company that was into that in 2019, and literally the fourth quarter of 19. And they benefited hugely because everybody who was in the pharmaceutical industry was buying their tools as the pandemic unfolded. So in any case, there's a lot of things going on in PLM and digitalization. And I thought it might be good to get PROSTEP's definition of what is digitalization here in 2023. Isn't it just a bunch of CAD files that we pass around, or is it?
I think it's really kind of a broad topic. If you take a look at how we have conducted our businesses over time, it's been primarily people and documents. For example, I don't know if you're familiar with how the advertising industry has evolved over the last 30 years or so. There was a time before Adobe and all of the design products where you had entire rooms full of people who did paste ups and artwork and red lines and all those kinds of things. And then these digital technologies started coming along where images were not stored on film, they were stored as files, and they could be manipulated as files. And so the very first part of digitalization is digitalization of documents. So instead of sending a fax, you actually send an electronic copy of a page or a PDF. Right. And so we begin converting information from documents into digital files. And then the challenge then thereafter is, well, okay, so now I just email the document, so somebody else prints out the document. How different is that? Well, there's two important things there. Is one, you're still document-based. Two, how do I know the document that you printed is the same as the document I have or document I printed? And so version control starts becoming a real big challenge as I talk about digitalization. But the big thing is we're going to be moving from documents, if you will, to data. And then once I've moved to data describing documents or describing objects, all right, the world begins to change. And so anyway, digitalization is the move from solids to data, from documents to data. And how often do you send an email right now as opposed to sending snail mail?
Yeah. So there are a lot. We have a lot of discussions about models and data and making decisions on this instead of on document reviews and so on. But it occurs to me, what's going to hold us back? And the one thing that I still stumble on is the industry that requires documents, which is the legal industry, right? When we contract and so on. Do you see those folks? And I'm really saying, can a contract become just data? And of course, sure. You need configuration control, as you mentioned. But
yeah, sure. Running a little left or off field, if you will, for a minute, that gets into the whole smart contract element with blockchain, which is, I think, kind of stumbling right now, but figuring its way along. But sure, in the end, is there any reason that a set of agreements well, put it this way, if I type up a contract, all right, I'm describing a set of interactions, proposed interactions, one could build a flow model out of that. And it's code, if you will, for the legal industry. And once I talk about code, I could put it into a computer and I could have it acted upon. In fact, that's a whole other discussion. We get into AI a little bit. But yes, you could have a set of agreements that were triggered by various events. For example, receipt of proof of delivery would trigger a payment automatically. Okay. And so the short answer is, from a contract perspective, yes.
Well, so it's interesting to me. We had, as you might expect with a supply chain at a car company, we had these documents, which of course were all digital, as you described, but they were still hundreds of pages. So if you wanted to supply us a part that goes into the next car, you still had to read through these pages. And a lot of them were, this is the way we want you to test it, and this is the way we want you to do sample control. And, sure. So it's kind of the rules and regulations. But I always wondered, when would the rules and regulations really become models, right? And interactive models, right? Whether it be a process model or even the geometry of the assembly that you're going to fit into. And then, especially with key suppliers, well, you want to do that all together, right? You want to collaborate together. And so the modification of the model could happen on both sides of the, if you will, business interface. And I think, I don't know, sometimes I wonder if the judicial system, the legal system, is still trying to catch up, right? And they're happier with documents because they know what it means, and they can print one with a date on it and a signature and all this other stuff. So there's several technical challenges, Craig, with regard to
digitalization, but I think probably the biggest challenge is not technical at all. It's organizational and people. When I talk about digitalization, all right, I'm talking about essentially enabling the automatic or the automation of transactions that have been typically mediated by people. Okay. And so, in order for people to take action on, say, a purchase order, all right, they want to know about the purchase order. Well, really, can't that just happen automatically?
Right.
And do you need to know about it? Does somebody need to know about it? Or they just need to know when it blows up or there's a red warning or something? So what knowledge do you need of the PO? And so what ends up happening is the nature of work, the nature of organizations change. The nature of a basic enterprise today has evolved from Henry Ford's, the Industrial Revolution. Then Henry Ford essentially defined the modern enterprise. And then we still look at that. We have people, we have finance, we have engineering, we have manufacturing, we have purchasing, you go through all the silos and you can find those going all the way back, right? Mm-hmm. And collaboration always meant that people had to bring their stuff to some central place and begin exchanging stuff and explaining stuff. Well, what's changing right now is that we're not just going to be data sharing. Collaboration will become much easier to do. In the same way right now, whether it's, I hate to use the word Facebook or what have you, but families today many times collaborate on many things just over Facebook because they have a platform with which to do it. Right. Mm-hmm. So I think the biggest challenge is how will organizations evolve and how will they become comfortable with allowing things to happen automatically and digitally that they used to have their hands on. Well,
and so interestingly enough, right, the last few years, the pandemic, and we have to do what we're doing right now, we're Zooming, right? We have to work collaboratively, and it's been digital technologies, communication and models and so on that have enabled us to work remotely and still be very productive. In some cases, more productive, which is kind of telling, right? Some of those maybe manual face-to-face things were quite inefficient, and the pandemic caused us to dispose of them because we didn't find them necessary. Mm-hmm. It's kind of interesting silver lining, if there could ever be a silver lining in a pandemic. But so do you call this the digital thread or the digital enterprise? There's also another term.
I think now there's a big difference, I think, between the notion of digital enterprise and digital thread. And so I think let's move on to digital thread, if you will, because that's a lot more specific. I think digitalization is industry-wide. It's happening across governments, households, enterprises, and what have you. And, right now, you stream something as opposed to getting it on CD. So, let your imagination run wild. But digital thread now it's very interesting because what we start talking about is if I wanted to go from the beginning to the end of a product, when I say the beginning is somewhere along the line, somebody has an idea, a bright idea, or maybe not so bright. And so we call that conceit. Right? They conceive the idea. And then somewhere between there and you as a customer purchasing it, all right, which would be receiving it, receipt. So conceit to receipt, if you will, is one way to look at the digital thread, all right? Mm-hmm. Now, it's real easy if I'm talking about an individual piece of some kind, a bolt or a nut, if you will. Right. But all of a sudden, if I start talking about two more things that are important here, one is, well, how often do you buy something that's just a single thing, right? More often than not, it's comprised of many things that have come together in some kind of an assembly or what have you, and particularly in our business. And then once you have receipt, and the big one right now is cell phones and computers and what have you, is, well, what happens with it when You go downstream, it's no longer, it's sitting in your drawer. It becomes a distributed source of resources, valuable resources, rare metals, right?
Yeah.
That are, once were in one location, are now distributed as if in the ocean all over, right? And so if I really want to talk about digital thread, I want to talk about beginning to end and back to beginning.
Yeah.
So all right. And one can begin thinking about individual steps along the way. And we do that now. You move from engineering to manufacturing, from E-bomb to M-bomb and what have you, right?
Right.
But if I were to try and go all the way around and I wanted to somehow at least have visibility to what was going on, because if I want to optimize something, how do we begin to do that? Right? You have to have some sense of it, and right now it's difficult. So digital thread holds a promise of connecting data and information related to a product from beginning to end through time.
Yeah. I'd like to get your reaction to something. There's a gentleman I work with off and on from Gartner, actually. His name is Dr. Mark Halpern. And Mark coined, it's a couple years ago now, this notion of, so he was talking about digital twins, but the thread came back, okay?
Yeah.
And in particular, he said, we don't really have a thread, we have a web. And his point was that we have a bunch of threads that interact and connect at different points in time. And in fact, the manufacturing guy has a different collection of threads, though there's some commonality with product engineering. And more importantly, there's some commonality with the end user, right? The person that uses that product. So he called this the digital web. Yeah. And digital twins were in fact nodes inside the web where things came together, the things being digital threads. And so I find it kind of fascinating because the nodes represent decision points. And the order of decisions is what makes a product really great. And you get feedback from a customer, you make other decisions on improvements or repairs if it's a quality spill.
Sure.
And so I like that notion a lot. And I think digital enterprises should be about digital things that connect you to make better decisions, and however you do that, right? And
well, I think there's 2 or 3 points there, Craig. Again, not wandering too far away from PLM and where we are in digitalization. I tend to think of it as fabric, digital fabric.
Yeah. It's a better way. It is a fabric.
And when you start talking about optimization, there's some very good visuals that have to do with neural networks and how they learn. And fabric is a way of kind of looking for optimum and minimum and what have you in those. So I hadn't heard the notion of a node being the intersection of 2 threads, although I get it. I tend to think of, or a digital twin being a node. I tend to think of the digital twin a little differently than that, but I will take that under consideration. If are you familiar with blockchain? I assume.
Aware. Familiar might be overstated.
Yeah. The idea there is, can I create a digital artifact that is one-to-one related to a real object, which can't be copied or duplicated independent of the real object? And so that's really kind of what a digital twin to me means, is there is some manifestation capable or possible from that digital twin, some expression in the real world. And so, I
like that. That's a whole lot better than what a lot of the classic PLM vendors, I'll just group them all together, claim a digital twin is, right? They're thinking back to the 3D mock-up and a visualization of an assembly, and it doesn't go any further than that. And that's certainly a really simple example of a digital twin, but it needs to be a whole lot better. I like what you're describing, a unique handle, if you will, to something in the real world. That's really good.
Yeah. Well, for example, if we take a look at digital printing, and one of the things, we've got a little project going here at PROSTEP called Sample, which is which is secure additive manufacturing platform, by the way.
Okay.
Everybody's got to have an acronym. But let's say I have a print file for a fastener of some kind, or any other kind of object which is highly engineered or what have you. And in the past, what we've done, and this is where the Navy is very big, what we've done is we've actually taken and manufactured those with stamping or what have you, sort of raw materials and what have you. But it's conceived, or injection molding. But it turns out then when it comes to MRO or replacement parts, I really don't want to have to store 4 million tons of fasteners.
Yeah, and right. Additive gives us a way to not store them, just wait.
Exactly. I can store the information and use it as needed in much the same way that you don't have to do CDs anymore or books. Far that goes, you can put them in a Kindle. Or you can put your CDs, you can stream it on Netflix. So the idea then becomes, in the past, when it came to royalties, engineering, quality control, and all of those kinds of things, they were all handled by the fact that I'm manufacturing these things, I'm storing them, I'm shipping products that I know everything about. And so what ends up happening is if I go to 3D printing, okay, how many of them should I allow to be printed? How do I know where they are? What are the transactions that occur? How do I know the process they used was correct? And there's 1,000 things that go on there, all right? But the opportunity is to come up with a platform that allows you to license the manufacturer according to standards, particular parts for which the expression of that part, right, from the digital format will be a physical twin of the digital twin.
Yeah, the additive, of course, is a brave new industry, and it's it's picking up steam already, and even in mass production for cars. It's just a question of volume, and they'll ramp up volume like we always have in the past. But I came across an interesting conundrum recently. Somebody pointed this out to me. In some of the additive applications, they're printing in a block several hundred parts because it's just efficient to do that. And then they cut them apart. So imagine a steering linkage or something that there's 100 of them made together. Well, in order to put them into that 3D space efficiently, the printer doesn't care. So you orient them in whatever direction, you can fit them all into a 1 meter by 1 meter by 1 meter cube, right? Or something like that. The failure that somebody was pointing out to me is the way, and this is mostly metals that were being used, right? But the way you lay down the layers, right? You create, in effect, a grain in the parts.
Yeah.
And the grain in the parts varies because the part orientation varies in this block that you're quote unquote additively manufacturing. So interesting was, okay, I not only need to know that it is a printed part, I need to know maybe what's the orientation that it was printed in, so that if a part with, let's say, a 15-degree off-center tilt has a grain pattern that's more reliable or less reliable because of the loads that part takes on. I just found this fascinating. This is a discovery that happens with new technology, right? You start applying a new technology and you're like, oh yeah, when we cast all those parts with molten metal, that problem didn't develop because there's no notion of grain, right? But now there's grain. And by the way, it probably isn't a big deal. It's just something to be aware of in case you see failure. So think about serialization. Your point about a unique serial number, if you will, for each part. You'd really like to keep this little piece of information too. What was the orientation in the block before it was solved apart, right?
I would consider that part of process. And so, a process control. And so
it's like the old saying in the car business: parts manufactured on Monday, you don't want them in your car, right? But that's a bad story.
I guess one final touch on kind of that aspect of it is actually 2 points, I think. Is one, when you think about digital printing or additive, okay, well, casting is additive, injection molding is additive, all right? So the question is twofold: is to how granular are your additions, okay? And with 3D printing, they're very granular. And two, how much energy is required to actually transform from the raw material to the finished material? And that's where you find out that 3D printing, if you've got to do a lot of it, doesn't scale very well compared to injection molding or many other traditional processes. So
it's just because it requires a lot more energy as you add?
Well, if I look at energy per unit of motion or unit of mass moved, yes.
Interesting.
Yeah.
So then it's not as green. Oh, no. Now we'll have another debate.
Right, exactly. But if I need just one piece of something, and this is where I get to the Navy, which is important, is the Navy can't stock all of their spare parts on an 8-month cruise that they'll need on an aircraft carrier. Okay. So from the very early days, and you'll find steam fitters and pipe fitters and welders, there were machine shops on ships and powdered metal, by the way, as well as raw stock. So they would stock the raw materials, the knowledge about how to make stuff in people who knew how to do the processes. They were machinists in the Navy. And so the Navy has been at the forefront of specialty manufacturing, to engineering drawings or engineering requirements on one-off pieces and one-off parts. And so they are really experimenting, along with Boeing, by the way, is the aircraft industry, with regard to, all right, when it comes to MRO, again, I can't distribute parts far and wide enough to cover all the needs, but I can distribute information. How can I take advantage of that?
Yeah. And for our audience that you aren't follow the part of the business Jim and I are talking about, it's maintenance, repair, and overhaul, which for the military especially is a really big deal because their volumes are much smaller than maybe what a commercial company would be.
Let me make one final comment on digital thread, okay, and then we'll kind of move on. So the real challenge with digital threads is, okay, if I've got a product that is going through many different engineers in different companies over time, how do I get a handle on what that looks like? All right. And there are a variety of platforms out there happening. We're experimenting with something we call OpenCLM at PROSTEP that essentially does two things: allows visibility and federates data. All right. What I mean by that is I want to eliminate moving or copying or duplicating data, because at any given time, when I look into the fabric or the digital thread, I want to make sure that the data that is supporting it is the current and relevant data, and not a copy that's been pulled somewhere and all of us have been burned by grabbing the wrong version of something. So this is a good lead into my probably going to be my last question at the rate I'm going. But is there an industry that's particularly good at all of this digital thread and making sure that it's done well, or is there an opportunity for improvement? Are there industries that are done that are really, really well? Well, I would say that the industries that you would expect are probably leading, and there's various people in there. But do I think it's there yet? No, and I'll tell you why in just a minute. Manufacturing, obviously, is a big one. And when I say manufacturing, there's discrete and process. I think process manufacturing, as opposed to discrete, might be farther ahead of the game because of the nature of their work than others, although I would need to think about that for a bit. Mm-hmm. Surprisingly, the construction industry, which has had a long history of BIM, is building information management systems, and really began back in the late 80s with regard to, or early 80s with regard to standards that allowed the digitalization of the industry. And they were one of the first places where I saw AutoCAD, and I saw architectural systems, what have you. They're actually doing quite well. Healthcare, I think up and coming, and digital twin technology will be very big there because of the nature of having to track things. Retail, changing quickly. Energy and utilities coming up behind, but might move more quickly because it's enabling simulation in MBSE. which is going to be very, very critical to optimization. So manufacturing, construction, healthcare, retail, energy.
Okay, interesting. And manufacturing, of course, everybody, especially car companies, it's all about the money you got to go borrow to make the next plant. And that's a lot of money. So you get really focused on the handoff between product engineering and manufacturing engineering,
Absolutely.
and then learning from your factory and improving. So, so Jim, my last point, why PROSTEP? Why are you guys at the center of this, and how can you help people?
Well, PROSTEP has been around for quite a while, and we're part of PROSTEP IV, which is the standards organization that's been at the beginning of this for PLM almost 30 years ago. And we're vendor neutral. All right. So we're interested in supporting organizations who need to migrate data, pick new systems, transform data, or collaborate. And we've got expertise all over. Interesting, if you want to take a look at people who are trying to hire PLM SMEs, there are not as many out there as you might expect. There's a skill shortage out there. So we provide that. And the key notion is we're vendor neutral there. And so whether it's a Dassault system or a AutoCAD, and I want to make one other point is collaboration happens not only across engineering and PLM systems. When you talk about digitizing an enterprise, well, wait a minute. There's an ERP system. There's an ALM system. There's an inventory system. There's a procurement system. There's an engineer. There's a manufacturing system. All of these people have tools, right? And systems that need to talk to one another.
That's right.
We enable that.
Okay.
And so we're not just PLM. We enable the dream of product lifecycle management end to end, the full circle.
Thank you. That's great. It's a good summary. Tom, back to you.
Hey, Jim, thank you so much for joining us here on the Digital Enterprise Society podcast. And thank you to everybody who tuned in and listened. You know what? You can learn more about what we talked about today by visiting digitalenterprisesociety.org. And we encourage you to leave your comments in the show notes or on the platform where you get podcasts, because the more comments we get, the more ideas we have of what we're doing right here on the show. And then join us again every week for more discussions about organizational transformation through the use of digital tools and techniques. Remember, here's where you come for more ideas, thoughts, and actionable information that'll help you navigate your career in and around PLM.
You've been listening to the Digital Enterprise Society podcast. Learn more about what you've heard here today at digitalenterprisesociety.org. Join us again next week for more connection without boundaries and creation without